Wow! Hello, hi everyone. Welcome to the Student the Brand. Oh my God, so much topic, so much topic. After finally so much traveling. Okay, so finally I reached to the right place to deliver the content. Yeah, this is your Siva sir. I'm delivering the content of light reflection and refraction CBSE Grade-10 physics. Many people are asking, so are you a delivery guy, are you a delivery guy, so why you are wearing helmet and why you are wearing so like that. Yes, definitely I am a delivery guy. So I am delivering the knowledge, I am delivering the knowledge CBSE Grade-10 physics, right? Yes, ready let's be ready to receive. Yes or no? Are you ready to receive our delivery? Yeah, of course. Come on. Yes. So thank you, Samaya. Thank you so much. So today topic is light reflection and refraction chapter. Light reflection and refraction chapter, right? Yes, come on, get into the topic. Light is a form of energy. Light reflection and refraction chapter. Light reflection and refraction chapter. So today we are going to discuss about this topic. So based on this one, few questions. So it's like a revision. Electricity, Somaya, yesterday only I completed electricity. So maybe you didn't join, I hope. So just yesterday only, same time. So 9 o'clock, so around 9 o'clock I completed the session. So today a little late because so much topic, huge topic. So that is the reason. Still, so I need to deliver my order. So you, okay. So you kept that. That is, you need to receive the order. So that's why I came. Whatever it happens, whatever the time it is. So I'm working so hard to deliver the content. Yes, of course. Yes. So Sivani, hi, good evening. Okay, then come to the point now. So now we are going to discuss about light reflection and refraction chapter. So reflection. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. So when light incidenting on it, okay, so now so light is a form of energy which gives the reflection of light. So today topic is reflection. I'm taking the plane mirror. So few questions I will ask. So be ready to answer those questions. So I'm taking the plane mirror. So this is the plane mirror. So this is the incident ray, and this one is the reflected ray, and the line which is perpendicular to the plane surface is called normal line. So the angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Okay. So now you can observe here. Okay. So here this is the extended incident ray. The angle between reflected ray and extended incident ray are, so undeviated line is called angle of deviation. I hope it is very clear, right? Yes. Now you can observe here. Reflection. What is the reflection? Reflection is nothing but the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light, or so simply reflecting back of the light from the reflecting surface. So reflecting back of the light from the reflecting surface. Okay, now, right, that is about reflection of light. Now laws of reflection, laws of reflection, laws of reflection, laws of reflection, laws of reflection. First one is angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So second one is incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. Okay. So I hope it is very clear. So reflection, laws of reflection. Now linear angle is 180 degrees. Linear angle, what is the linear angle? Linear angle is 180 degrees. I am taking this linear angle is 180 degrees. So here angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Yes or no? Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Clear or not? Now you can see here angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So we know from laws of reflection we can write angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. We know that. So by that we can write Okay, so now angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Now you can see angle of incidence plus angle of deviation equal to 180 degrees. Now can we take angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence. I hope it is very clear. Just check once. Okay. Angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. Okay. So angle of incident is equal to angle of reflection from that. So instead of angle of reflection, I am writing angle of incidence. Right. So angle of deviation equal to 180 minus 2 angle of incidence. I hope it is very clear. So we can also write angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. 2 angle of reflection. 2 angle of reflection. I hope it is very clear, right? Yes. Now, come on. So let's go to the next topic. The topic is regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular reflection and irregular reflection. So regular reflection and irregular reflection. Now you can observe here. So regular reflection, irregular reflection. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Right? So be clear with that. So incident ray, this is the incident ray, and this one is the reflected ray, and I am considering this a normal line. The angle between incident ray and normal line is called angle of incidence. Oh, there's a regular reflection, right? Regular reflection means what? So incident light rays are parallel and reflected light rays are also parallel to each other. Yes, 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 yes. Incident light rays are parallel to each other. Incident light rays are parallel to each other. Reflected light rays are also parallel to each other. Then this type of reflection is called regular reflection. Incident light rays are parallel, then reflected light rays are also parallel to each other. Then this type of reflection is called regular reflection. Coming to irregular reflection, irregular reflection, irregular reflection, irregular reflection. Irregular reflection takes place on rough surface. Irregular reflection, irregular reflection takes place on okay, so regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Okay, okay, okay. I hope it is very clear. So irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Okay, so is it clear? Is it clear? Right. So regular reflection takes place on smooth surface, irregular reflection takes place on rough surface. So regular reflection example, plain mirror and still water. Irregular reflection takes place on we can take wall and paper also. Okay, done. Regular reflection, irregular reflection completed. Next one, object and image. Object and image, object and image, object and image, object and image. Na 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 la 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 na 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 real object and virtual image. Real object and virtual image. Na 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 la 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 Hi everyone, welcome to the class. Welcome to the session. Welcome to the session of receiving content, receiving the knowledge. This is real image and virtual object. Now you can observe here. So light rays are coming from the object. After reflection, the light rays are moving away from the principal axis. Okay, if you are extending this reflector light rays, those reflector light rays are meeting at one point. Those reflector light rays are meeting at one point. That is called virtual image. So this is a real object. And coming to the one more, here you can observe light rays are coming from certain point. After reflection, those are meeting at one point. That is a real image. We are extending the incident light rays. Extended incident light rays are meeting at one point. There, so object, that is a virtual object. Their object is there. That is a virtual object. So here, by observing these two diagrams, we can conclude that by observing these two diagrams, we can conclude that one thing, that is object is real, image is virtual. Object and image. Object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. Sir, how can you say like that? How can you say like that? How it is possible? How can you say like that? Here you can see object is real. This is object real. Image is virtual. So extended reflector light rays are meeting at one point. That is a virtual image. Coming to the object is virtual. So object is this virtual because extended incident light rays are meeting at one point. Extended incident light rays are meeting at one point. So there is a virtual object and image is real. So this image is real, right? Image is real. Okay, so this is about object is real, image is virtual, object is virtual, image is real, right? Next. So this is very important concept. Next one, coming to the plane mirror. So plane mirror, so nature of the image formed by the plane mirror. So coming to the plane mirror, 3 marks question. Even this also they will ask for 2 marks. Even for MCQs also very important. If the object is real, image is virtual. If the object is virtual, image is real. Vice versa. Vice versa, it will happens. Okay, so now now you can see here. So I'm taking the plane mirror like this. Plane mirror, 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 plane mirror. So this is the object I'm taking here. Object A, B here. Okay, how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. So here now I am considering one light ray I am taking like this. After reflection, so if the light ray is passing along the normal line, if the light ray is passing along the normal line, so it retraces its original path. It moves in the same direction. So it goes back in the same direction, right? Yes. Now one more light ray I'm taking like this. It after incidenting, it will be reflected back, and here also we can take and here. So if you are extending these light rays, these light rays, okay. So here, A dash and B dash, A dash and B dash, okay. So now you can see here, A dash and B dash. Here you can observe, first point, object is real. Object is real, image is virtual. Object is virtual, image is real. So coming to the second point, object distance is equal to image distance. Object distance is equal to image distance. Coming to the third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. I hope it is very clear. Now, so plane mirror also forms magnification. Magnification of the plane mirror is +1. Sir, why magnification of the plane mirror is +1? Okay, so now you can take here, object is real, image is virtual. Object is virtual, image is real. So that's the point number one. Point number two, object distance is equal to image distance. So what is object distance? The point is, what is object distance? I have a question. So what is object distance and what is image distance? So how to take? See, if I mention many times also, general basic questions. So the basic questions people will do mistakes. What is object distance? What is image distance? Object distance is nothing but the distance between object to mirror. Object distance is nothing but the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. That's enough. Very simple, right? Very simple. The distance between object to mirror is called object distance. The distance between object to mirror is called image distance. So object to mirror, object distance, mirror to image, mirror to image is called image distance. So that is the 2 points. And point number third is height of the object is equal to height of the image. Height of the object is equal to height of the image. So object distance is equal to image distance. Height of the object is equal to height of the image. Magnification is +1. Magnification is +1. Okay. I hope it is very clear. Just check once. So these are the points. Now next. So we are going. This is about plane mirror. This is about plane mirror. So we'll discuss about spherical mirrors. Spherical mirrors. Spherical mirrors. Sir, what is spherical mirror, sir? Spherical mirror is nothing but the mirror which is in the form of curved shape. The mirror which is in the form of curved shape is called spherical mirror. There are two types of spherical mirrors are there. Concave mirror and convex mirror. Concave mirror and convex mirror. How can you say one is concave mirror, another one is convex mirror? How can you say? Let me know. So concave mirror is nothing but the mirror whose reflection takes place inward. That is called concave mirror. Convex mirror means the mirror whose reflection takes place outward. That's enough. Once again, come to the point. So this is a concave mirror. Concave mirror. The mirror whose reflection takes place inward. This is the concave mirror. Concave mirror. Concave mirror. Okay, so concave mirror is also known as converging mirror. Converging mirror. Sir. What is converging mirror, sir? Sir, why concave mirror is also called converging mirror, sir? Sir, why you are calling concave mirror is also converging mirror, sir? And one more thing, convex mirror is also called diverging mirror. Convex mirror is also known as diverging mirror. Convex mirror. Diverging mirror. Diverging mirror. Convex mirror. Diverging mirror. Sir, diverging mirror. Saru, why concave mirror is converging mirror? Why convex mirror is diverging mirror? Okay, so explain no, sir. Yes, concave mirror is also known as converging mirror because whenever light rays are incidenting on it, so if I'm taking after reflection, those light rays are meeting at one point. After reflection, those light rays are meeting at one point. That's why after reflection, light rays are moving towards the principal axis. So mirror is converging the light rays. Mirror making the light rays to move to one point. Okay, so it is making the reflection. So it reflecting the light rays. Okay, towards the principal axis. After reflection, light rays are moving towards the principal axis. So you can say anything. Okay, so however wish. The final thing is light rays are coming closer. After reflection, light rays are moving towards the principal axis. Our reference point. Normally, coordinate axis, you know, right? Coordinate axis origin is our reference point. Yes or no? Origin is your reference point. Yes or no? Origin is our reference point. The same thing here. Here you can take principal axis. Principal axis or reference point. After reflection, light rays are moving. Light rays are coming closer to the principal axis. That's why it is called concave mirror. It is also known as converging mirror. Coming to the convex mirror. After reflection, light rays are moving away from the principal axis. After reflection, so you can observe here, after reflection, light rays are moving away from the principal axis. That's why it is called diverging mirror. So they will ask, so draw the nature of concave mirror and draw the nature of convex mirror. You have to draw the concave mirror nature and convex mirror nature, means you have to draw these two diagrams. They will ask for 2 marks question also. 2 marks question. And names also very important. Concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. Yes or no? So these are very very important. Now, so let's start few more points. That is about terms related to spherical mirrors. Sir, I have doubts, sir. So, what is the meaning of terms related to spherical mirror, sir? Terms related to spherical mirror. So, terms, nomenclature, the basic points, the basic terminology, what we use. So, we had names, right? Okay. So, we had names to call a person. So, we had a names. So, here, sir. So, we had names, no, sir? Yes, I know. Student, the brand. Okay, like the different names are there. Like the different names are there. But for mirrors also names are there. For mirrors also names are there. Those are called nomenclature or terms related to spherical mirror. Terms related to spherical mirror. Let's start. Let's start. Okay. So terms related to spherical mirror. So I'm taking this a concave mirror. Concave mirror. This is a part of the concave mirror like this. Okay. So actually it is a sphere. Okay, it's a part of the sphere. Now, so this is the center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. So actually this entire portion is a sphere. In that it is a small portion is concave mirror. Concave mirror or curvature. Concave mirror, curvature. Okay, it is a part of the sphere. It is a part of the sphere. So the center of the imaginary sphere in which mirror is a part. So the midpoint of the mirror is called pole. Midpoint of the mirror is called pole. Midpoint of the mirror is called pole. The line joining of center curvature and pole is called principal axis. Saru, what is principal axis, Saru? Principal axis means the line joining of center of curvature and pole. The line joining of center of curvature and pole is called principal axis. Principal axis. After reflection, light rays will meet at one point on the principal axis. After reflection, these light rays are meeting at one point on the principal axis. Okay, so these are called this point is called focus. This point is called focus. So this is also called principal focus. Principal focus. Simply we can say focus, or generally we can say principal focus. Now the distance between the central curvature to pole, the distance between central curvature to pole is called radius of curvature. The distance between focus to pole is called focal length, small f. Focal length, small f, we can say. Okay. Now we can observe here point number one. Okay, center of curvature. Point number two, pole. Third one, radius of curvature. Fourth one, focal length, and fifth one. So center of curvature, pole, radius of curvature, focal length, and principal axis. Principal axis. Principal axis. And the sixth one, width of the mirror is called aperture. Width of the mirror is called aperture. Center curvature, pole, radius of curvature, principal focus. Seventh one is principal focus, or simply we can say focus. Capital F is there. principal focus, capital M. Okay, so these are the terms related to spherical mirror or nomenclature. Terms related to spherical mirror or nomenclature. I hope it is very clear. So this is about terms related to spherical mirror. Okay, now so we'll go to the another one, that is ray rules. Ray rules are very important. Ray rules are very important. So if you are going to war, how we need weapons. Okay, so weapons are very important. At the same time, if you are drawing the image formations, you need inputs. You need your weapons. Those are called ray rules. Ray rules. Ray rules. Ray rules. Ray rules. Come on. Ray rules. Da 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 da. Ray rules. Ray rules. Ra 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 re. Ra re. Ra ra re. Na na re na na. Concave mirror. Concave mirror. Concave mirror. Saru, what is concave mirror? Concave mirror is nothing but the mirror whose reflection takes place inward. That is called concave mirror. Now, I am taking the ray rules. So, this is a concave mirror and pearl, focus, center of curvature, pull, focus, and center of curvature. After reflection, light ray will pass through focus. After reflection, light ray will pass through the focus. That is the first one. Coming to the second one. Are you listening, students? Are you listening, students? So, light ray is passing through focus. Light ray is passing through the focus. After reflection, light ray is moving towards the principal. Light ray is moving towards infinity, parallel to the principal axis and moving towards infinity. Okay, so like this. And coming to the third one. This the pole, focus, center of curvature. So light ray is passing through center of curvature. So here, coming to the final one. So light ray will incident at the pole, it reflect back. Light ray will incident at the pole, it reflect back. So these are the one is light ray passing through the focus after reflection. Light ray passes through the focus. Here, if the light ray passing through the focus after reflection moves towards infinity, here light ray is passing through the center of curvature. Here light ray is incidenting at the pole, it reflect back. So these are the ray rules of concave mirror. Next one, convex mirror also same. So no changes in that. Convex mirror also same. Convex mirror will discuss. Convex mirror. Hey, Suresh. So, like your confidence, Suresh. Definitely, I will teach. Second point is, so again I will teach, no problem. I'll start from starting. So, the first point, pole, focus, center of curvature. Light ray is passing through the focus. Light ray is coming from infinity. After reflection, it passes through focus. Light ray is passing light ray is coming from infinity. So light ray is coming. Means when the light ray is coming from infinity, it will become parallel to the principal axis. After reflection, okay. So slight changes. So it's not a exactly accurate diagram. Some small humor errors. So please try to understand and accept it. Okay. So after reflection passes through focus. That is the first one. And coming to the second one is reverse of the first one. That's enough. So Suresh, user ID Suresh. So here this is the pole, focus, and center of curvature. So here after reflection passes or moves towards infinity. That is only answer. So I hope it is very clear, right? Yes. So light rays coming from infinity after reflection passes through focus. Light rays passing through the focus after reflection moves towards infinity. So is it clear, Suresh? I hope it is very clear. Mhm. Actually, this is the actually this is the way to explain. So just for understanding, I'm explaining third and fourth. Okay, very good. Thank you, Suresh. And remaining students, if it is related to content wise, it is related to concept wise, please ask doubts. You can ask doubts. Okay, then if the current topic, whatever the topic is going on that, if you ask questions, I can explain. Okay, so you, for you only I came with so much hard work. Yes or no? Radius of curvature. Radius of curvature is nothing but the distance between center of curvature to pole. The distance between center of curvature and pole. Okay. Formula of refractive index. So sin I by sin r equal to nu. Is it okay? What is aperture? Width of the reflecting surface. Diminished real inverted. So Suresh, actually, I didn't go to the still image formation. So now I'm explaining only ray rules. So first go through that ray rules. After completion of ray rules, we'll discuss about image formations. Ready? Get into point. Okay, done. Come on. Convex mirror. Convex mirror. Convex mirror. Convex mirror. Convex mirror. So Deepak, magnification, the ratio of height of the image by height of the object. You had so many questions in your mind to ask me. Oh, thank you so much, Deepak. Oh, correct. Correct. Thank you so much. So, no, generally I will tell the answers. No, no one will respond whether it is correct or wrong. But thank you, boss. You responded to my answers. Okay, then come to the point. So, convex mirror image formation. So, I'm taking like this. First one. So, pole, focus, center of curvature, pole, focus, and center of curvature. So, light ray is coming like this. After reflection, moving like this. It passes through focus, Coming to the second one. Mhm, mhm. So pole, focus, center of curvature. So light ray is passing through focus. So light ray is passing through focus. After reflection, it moves towards infinity. And coming to the third one. Third one. Third one. Okay, this is the pole. Focus, center of curvature. Light ray passing through center of curvature. Light ray is passing through center of curvature like this. Light ray is passing through like this. So fourth one. Mhm. Light ray is incidenting at the pole. So light ray incidenting at the pole, it reflect back. So pole. Okay. Center curvature, focus and pole. After light ray incident at the pole, it reflect back. Is it clear? I hope it is very clear. Mhm. So generally someone had so many concerns, so many doubts. Someone asked for the helmet. So now fine, happy, clear. There is notes I think on. Da, 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 da. Bro, so I will tell one thing. If I wear helmet also, if I wear raincoat also, my concept is same only. Okay. So concept won't change. Concept will goes on. Yes or no? Right. So this one I am delivering the knowledge. It is a symbol. Yes or no? I am delivering the knowledge. I am delivering the content. I am delivering the information. That's why. Right? Chalo. It is a symbol for it. Let's start. Turn on. Okay. So till now I completed. So ray rules completed. Now image formation. Image formation. Image formation. Image formation of concave mirror. Concave mirror. So image formation of concave mirror. Now I am taking first one is. Mhm. Mhm. So this is the pole, focus, central curvature. Pole, focus and central curvature. Pole, focus and central curvature. So object is at infinity. So how many light rays? One light ray I am taking like this. Another light ray I am taking like this. After reflection, light rays are passing. After reflection, so this is focus. So object is at infinity. Image is forming at focus. Image is forming at focus. Nature of the images. Nature of the images. Nature of the images. Real and inverted and highly diminished. Real, inverted and highly diminished. Coming to the second one. Coming to the second one. Pole, focus, central curvature. Object is placed beyond central curvature. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object, right? So that's why I'm taking one light ray I'm considering here. After reflection passes through focus, another light ray passing through central curvature. So those light rays are meeting between C and F. Object is beyond central curvature, beyond C. Image is formed between C and F. Image is formed between C and F. Nature of the image is real and inverted. Nature of the image is real and inverted. And coming to the third one. Third one you can observe here. So pole, focus, central curvature. Object is placed at central curvature. How many light rays? One light ray I'm taking like this. It passes through focus. Another light ray incidenting at the pole. Another light ray incidenting at the pole after reflection. So these are meeting at central curvature. Object is pole. Object at central curvature. Object is at central curvature. Okay, so here object is placed at central curvature. Image also forming at central curvature. Object is placed at C. Image also will form at C. Nature of the image is real and inverted and same size. Real and inverted and same size. And coming to the fourth one. Coming to the fourth one. So pole, focus, central curvature. Object is placed between C and F. One light ray I am taking like this. It passes through focus. Another light ray. So incidenting at the pole. So it will be reflected. Object is placed between C and F. Image is forming beyond C. Beyond C. Nature of the image is real and inverted and enlarged. Only in this case only real, inverted and same size will get. And coming to the fifth one. So pole, focus, center of curvature, object is placed at F. One light I am taking like this, it passes through focus. Another light incidenting at the pole, it will be. So object is at F, image is forming at infinity. Nature of the image is real and inverted and highly enlarged. Okay, so last one is, so very very important, sixth one. Object is placed. So pole, focus, center of curvature, object is placed between F and P. One light I am taking, it passes through focus. Another light ray incidenting at the pole, it reflect. So if you are extending those light rays are meeting. So extended light rays are meeting. So behind the mirror, extended light rays are meeting behind the mirror. So nature of the mirror is virtual, erect and enlarged. Okay, so thank you so much for joining and attending and listening my lecture. So today I delivered that is light reflection and refraction chapter. So in that reflection part, in that, so concave mirror image formations, thank you so much for joining and attending and listening, and so for receiving my lecture. Thank you so much. This is our Shiva sir from Student Brand. If you like the content, if you like the lecture, so whatever I delivered, so please do like and share and subscribe my channel. So thank you so much. So we'll see you in the next class. Thank you.